Hi everyone, today in Integrated Math 2 we're going to go over Chapter 5, Lesson 5. Here are the objectives. Make sure you write them down in your notes. So, corresponding angles postulate. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So in this example, as you can see, these little arrows, that means parallel. So these pink ones mean that they're parallel to each other. So I'll make a little note. So we know that angle 1 right here is congruent to angle 3. And we know that angle 2 is congruent with angle 4. Angle 5 here, 1, 2, 3, is congruent with angle 7. And angle 8 is congruent with angle 6. These are all corresponding angles for each other. Parallel lines and angle pairs, alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So as you can see here, angle 1 is congruent with angle 3. And angle 2 is congruent with angle 4. They're alternate interior. So alternate means opposite sides, they're not on the same side. And interior means that they're inside. Think about the interior of your car would be inside your car, or interior design is design inside the house. Then we have consecutive interior angles theorem. Two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Supplementary is when they add up to equal 180 degrees, two angles. So in this case, angle 1 and angle 2, those two would add up to be 180 degrees, just as angle 4 and angle 3 both would as well. Alternate exterior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. Alternate, opposite sides, so 5 and 7 are opposite sides, and so is 6. But it also does say exterior angles, so opposite sides and their exterior. So 5 and 7 are opposite sides and their exterior, and 8 and 6 are their own pair as well, which means they're congruent to each other. So circles with circles and squares with squares. Perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. If line A and B are parallel, that's what these arrows show, then line A is perpendicular, that's what that symbol means, to line T. There we go, which is shown here, which is why we have 90 degrees. Then line B is perpendicular to line T. So both of these would be perpendicular, resulting in the angles to be 90 degrees. So let's try this example. If the measure of angle 5 is equal to 7x minus 5, and the measure of angle 4 is equal to 2x plus 23, find x and explain your reasoning. So I'm looking here, I know there's something going on between 4 and 5. Well, 4 and 5 are supplementary angles. Remember, they add up to 180 degrees. So because I know that, I'm going to say the measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. That's because of supplementary angles. And I know the measure of angle 4 is 2x plus 23. And I know the measure of angle 5 is 7x minus 5, which is equal to 180 degrees. All I did here was simple substitution. Now I combine like terms and simplify. So 2x plus 7x is 9x. I can do this because they are on the same side of the equal sign. Then 23 minus 5 is positive 18, which is equal to 180 degrees. Then I still want to solve for x, so I'll box the 9x minus 18 to both sides. So 9x is equal to 162. The box becomes smaller. Divide 9 to both sides. X is equal to 18. So I've now found out what x is equal to. And we also know that since lines L and M are parallel and angle 4 and 5 are supplementary by the consecutive angles theorem, because of all that, I know x is equal to 18.